Oke, siap ya. Satu, dua, tiga. Ntar gua edit. Assalamualaikum warahmatullahi wabarakatuh. First of all, let me introduce myself. My name is Adnan and I'm with my college. So here we are trying to explain to you about real-time UAV surveillance images enhancement using the slant transforms. And process mathematical technique to reduce noise, and increase image clarity with low computational cost, making it ideal for real-time UAV surveillance. In our project, we combine the slant transform with DCT and hard transform to improve image without slowing the system. Okay, so before we go into the results, we should know about the method that we use about this image processing. So we use a slant matrix construction. As you can see in the screen, the first row is with S sub 1 V equals 2 V minus 7 all over 7. And in the third row or higher row is S sub U V equals square root of 2x times cosine of open parenthesis 2 V plus 1 close parenthesis times U P over 16. And then what if we convert it into blocks transformations? It becomes T slants equal S times B times S transpose. And then if we also change it into cosine transforms, it becomes T dct of U V equals alpha U times alpha V times the double sum from x equals 0. And also, after we finish all of these things, we should normalize the factor. So it becomes alpha u equals 1 over root 8 if u equals 0, otherwise the square root 2 over 8. Okay, so this is the results that we already been taken by doing the Python or like by doing the simulation in the Python wavelet. At first, I'm trying to make or trying to process the image without using slants, and also I'm using a grayscale. As you can see, we cannot show the exact image at the above, but and then I'm trying to mix it with the slant transforms. And at the second picture, as you can see, is much more clearer, even though we cannot see the real or like almost the original picture, we still can recognize what inside those photos, what inside those pictures. And then after we combine everything, it become a hybrid transformations. As you can see at the bottom of the pictures, it's still blurry, but if we filtering again, it will become much more better than the original versions. Or maybe it can be used at the real time, especially in the war zone, right? And then for results and discussion, I'm trying to compare it again with the William K. Pratt paper. As you can see, these two are almost the same pictures, but the first one is without any slant transformations, and then when we combine it into the slant transformations, it become more recognizable. We can see the eyes, we can see the smiles, because slant transforms is not used here to show the baseline performance. Slant transforms is enhancing the image, so it becomes more sharper and easily recognizable for human and AI. Because DCT and DWT only provide basic enhancement. Maybe DWT gives better results than DCT for edge and texture. But as you can see in the slide before, the tanks still look blurry, even pixelated. And and in my project, in our project, our transformations is applied blockwise 16 times 16. So it improves directionality and also captures and edges features often missed by DCT and DWT. And also, if we move it into the PSNR or peak signal to noise ratio, the slant transforms it's a little bit much more sharper in decibel than DCT and DWT. And also, we combine the CLAHE as well. It stands for contrast limit adaptive histogram to make the technique and make the contrast more bright, especially some regions or like some pixel that looks darker than any other regions.
Conclusion. Every image transform has its strengths and weakness. DGT, DWT, and DCT, and slant. In our project, we combine three transform, not just comparison, but also to maximize image
Enhancement. Enhancement.
enhancement. The result is a system that works effectively
In real
in
time.
real time, a key
Requirement.
requirement for
You
UAV surveillance, where speed
speed
and quality are both
essential.
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 Uh, these techniques can also be applied beyond
UAVs.
UAVs in daily life application that need fast and reliable image enhancement.
Okay, I think that's enough for us. I'm really sorry if we do have a lot of mistakes, and I want to say thank you for William Caprat as well for giving me a lot of inspiration for my paper, and I want to say thank you so much, and you should say thank you as well.
Thank you so much.
Thank you so much for everything, especially Bu Asti. Wassalamualaikum warahmatullahi wabarakatuh. Nah.